Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. Today we are looking at this question. It says, consider the equilibrium, and that's the equilibrium. It's between ammonia reacting with oxygen to give you nitric oxide and water, and the 2.5 moles of ammonia and 1.2 moles of oxygen are placed in 2 cubic decimeter container at 100 degrees Celsius. Okay, then we say 2.41 times 10 power 23 molecules of water vapor are present at equilibrium. 2.1, it says calculate the value of equilibrium constant. So how do we approach this? Okay, we are going to have the table, and okay, let's see how the table will look like. So this is the table we are having, and what we can fit into what we know. What do we know about the table? We know the ratios. This one is 4 from there. This one is 5. This one is 4. This one is 6. Okay. After getting that one, what do we do? We also know the initial number of moles. They are here. We have that one for ammonia, which is 2.5. And you have that one for oxygen, which is 1.2. Now we have to remember something. This word, I highlighted it for a reason. We say this number of moles are placed. What does that word mean? It means that reaction is just starting. And at the start of reaction, what do we know? At start of reaction, we only have what? Reactants. We don't have any product. So that's why this one is 0 and this one is 0. Okay, that one is catered for. Then we come here. We have the number of molecules of the water vapor formed. Water vapor is this one. So at equilibrium, we know this. But do you know what? What we have here are number of molecules, and what is supposed to go in the table is supposed to be number of moles. So what do? We perform calculation to change the number of molecules to moles. How do you do that? We use the known equation, which says N is equal to number of entities over Avogadro number. So what is the number of entities? It is 2.41 times 10 power 23. And what is Avogadro number? 6.02 times 10 power 23. This one gives you the number of moles. So let us press the calculator and find out what we have. So we get the number of moles as 0.4. So we put it where it belongs. Okay. There's something you have to know, which is very important here. Okay, you have to know that during the reaction, when the reaction is just starting, there is only one direction, and the direction is what? Forward. Forward means that whatever you have here is going to reduce, and whatever you have that side is going to add. At the start of the reaction, there is only one direction, and that direction is forward. Okay, so these are the signs. So what does that mean? That is 0 plus the figure which is here, you are going to get 0.4. So what is the figure here? 0.4. Is that okay? So after getting that one, there's something which is very important to you. What controls this figure in this part are the ratios. So it's high time we perform those simple calculations to find out our figures here. Okay, let's see what we can do. Okay, let's start with the nitric oxide. We have nitric oxide. The ratio is 4, and you have water vapor, and it is 6. And the water vapor, we know it as 4. This one is x, and you cross multiply. You'll get 6x, giving you 4 times 0.4. So x is going to be 4 times 0.4 over 6. What you get there is going to be the number. So we have got the number. So the number is 0.27. So this is 0.27. Okay. Let us now perform for this one. So you come to oxygen, you say 5 oxygen and 6 water. The ratio is 5 to 6, but for the water we know it's 0.4. This one is x. So what is going to be our x after cross multiplying is going to be 6x, giving you 5 times 0.4. So x is going to be 5 times 0.4 divided by 6. Okay, what do we get from there? So you get the answer as 0.33. So that's what you get, and you put it there. It is 0.33. Okay. Now we come to this side, but remember this number is the same as this one. So this one is going to be the same. So what are you going to put here? 0.27. Okay. So after that, what do we do? Remember, these are subtractions. So 2.5 minus 0.27, you get the number of moles in at equilibrium. 1.2 minus 0.33, you get the number of moles here. 0 plus this, you are going to get 0.27. So let's see what our calculator gives us there. So after getting this number of moles at equilibrium, we can go ahead and calculate the concentration. You have to remember the concentration is equal to number of moles over volume. So you're going to divide, and the volume is known. Volume is 2 cubic decimeter. So you're going to divide each one of this one by 2. And let's try that one and see what we get. Yeah, so after getting the concentrations, the next step is to get the expression. So the case expression from here is going to be the concentration of the products, which is NO here, to the power 4, water vapor to the power 6, divided by ammonia to the power 4 into oxygen to the power 5. Next is to substitute. So what do you get? NO is 0.135 power 4 times water vapor 0.2 power 6 divided by ammonia is 1.115 to the power 4 times 0.435 to the power 5, and what you get will be the Kc value. So that's what we are supposed to do. Okay, after computation we get our Kc value. Okay, so let us look at the next question. Okay, then comes this question. It says, what is the significance of the Kc value calculated? So how do you answer this question? This question requires us to look at the Kc value. I want us to look at it closely. It is 8.83 times 10 power minus 7. Very small. Okay, what is the significance of that? The significance is that the Kc value is too small, means that the yield is too small. That's the significance. It has a bearing on the yield of the equilibrium. The yield is too small. Thank you. So that is that. So we are closing this video, and we would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard. See you next time. Bye bye.